Good afternoon, good morning, and good evening. Welcome to EIG's 50th webinar. Today's webinar is focused on unleashing the real-time, data-driven digital twin to accelerate Industry 4.0. Today, we will be joined by Hosni Adra of CreateASoft, and we look forward to your questions and discussion as we go through the webinar. Again, thanks for joining us. We appreciate you taking the time to join us in Enhance International Groups and CreateASoft's webinars series, especially in light of the coronavirus pandemic as it continues. We hope that your family is safe. Again, this is the third webinar in the series. In the previous webinars, we focused on how to build a digital twin. We'll review those slides so they're available for you, but what we'll try to get into is the actual digital twin of the granite company that has been modeled. We look forward to an interactive webinar. As we mentioned earlier, please do have your cell phone ready and open up another window in your browser and log into pollev.com/Jim DeVries 073. It's also in the chat window. Please do log in for the polling. We appreciate your feedback. A little bit of background on myself. My name is Jim DeVries, founder and president of Enhance International Group. And EIG is an exchange of passionate experts to guide your transformation to provide self-generating and self-funding results. We're a group of over 50 consultants, consulting companies, and SaaS providers that provide thought leadership in the areas to transform your company. You can view us like a Swiss Army knife. We have the tools and the thought leadership to serve you in anywhere you need to enhance your organization. With that, I'd like to turn it over to Hosni Adra. He's the managing partner of CreateASoft, and he's been really working in this space for over 20 years, one of the pioneers in digitization of different environments, and has patents and a book and his state-of-the-art technology. Hosni?
Hello, everyone from Chicago. It's actually a nice and cold day today in January. It's not as windy as usual. As Jim mentioned, I've actually been doing simulation and digital twin implementation for about 30 years now. Many industries, from warehousing, manufacturing, healthcare, service industry, and continuous flow type operations type industry, food and pharmaceuticals, and so on. I have a number of patents on the industry, on the actual digitization relating to lean metrics and lean connectivity to the digital twin, to the on-the-fly modification of the models in the digital twin, and making those digital twin models actually learn and adapt to our daily environment. I'll go into the detail into how to be successful with implementing a data-driven digital twin today and cover some examples as we go along.
Thanks, Hosni. And as you can see, we're going to move from theory to practicality in this webinar. So again, this is the third webinar. Our next webinar will be on warehousing, which will be coming up in the next couple months. Our agenda today is a roadmap to Industry 4.0, smart manufacturing, an overview of our challenge to get there, a little bit of background on some techniques. Then we'll get into the data-driven digital twin, an overview by Hosni, and then getting into the actual digital twins, making it real with his real-life simulation. And then we'll go through and just summarize that, that this can be done in a very short period of time, basically a 90-day plan. We can get a line up and running within 90 days. Just as the focus, just to start us off, We all know the overarching drive of digitizing our networks from our supply chain to our factory floor to our offices. There's an overwhelming race to digitize. Most companies have digitization as their goals. And what we're covering in our series of webinars are ways to help you on that journey. And what we've laid out here is 5 steps to organize, standardize, visualize, stabilize, and optimize. You really have to go through these 5 steps. You can't just jump all the way to optimization without getting your house in order. And what's the one thing that tends to block us the most to getting there is data. As this IBM study showed in 2019, and it's still relevant today, is that about half of the challenges in digitizing work streams is lack of data. And from a quality and integration and a lack of understanding perspective. So we need to figure out, how do we get data into the system? The beautiful thing that Hosni does with CreateASoft and Wisers does with their system is they bring data immediately into your workplace at a very low cost and a very high return on investment. So that's the powerful perspective that we will bring today. And again, from a data perspective, we do need to be treating data as a competitive asset. We need to treat data very well. Most of the time we're looking at data in arrears. We run a report and look at it daily. That's looking at things in the rear view mirror. So that's what we call descriptive analytics, and drives more siloed type of reporting. And it's very hard to integrate across boundaries. And in the way to get predictive analytics to be very valuable is to drive it horizontally across the organization. And that's what Hosni will share with you, how he has done that over the years. First, you started manufacturing, and then you can expand out to supply chain, and how his real-time data-driven digital twin actually gives you that capability to orchestrate, to get to orchestration. So that problem statement is, how do we get up this move from left to right and get to the real-time analytics and real-time decision-making, not just analytics, but decision-making in real time on a daily and a moment-by-moment basis. So that's what Hosni will share with us. And again, we need to take that data, turn it into information and knowledge, so that we can get and use everybody's favorite buzzword of today, artificial intelligence, and making it a competitive asset. So again, this roadmap that we outlined of organize, standardize, visualize, you need to understand your processes, you understand your entitlement, your critical paths, your value stream maps. How do you do this automatically? That's the beauty of CreateASoft and Wisers. It will help you on your journey here. So from a Wisers perspective, from a tooling and consumables perspective, what it does is helps you through the 5 S's automatically, helps you from a sorting perspective, taking your inventory of your tooling, the consumables that you're using at your workstation, helps you shine your workstation, leveraging SpinWiser and standardizing and feeding these reports into a digital twin. What does that look like on the floor? Well, here's a typical manufacturing floor where you have some CNC machines. You see the green figures here, where you're tracking, you have tooling locally. So the machinist or the workers don't need to walk halfway across the facility in order to get a new tool or a new consumable. They're right there with you. And then if you are pulling things out of a store, you don't have to have people there. You can have lockers and use lockers to show things coming in and out. And so what does that look like? So from a Wiser's perspective, they have the smart lockers to track everything in and out, the shelving and the drawers or doors that get you in and out. You have the totems to track everything else, as well as the Spinwiser that tracks the tooling and consumables, all throwing into real-time reporting. That's a system that stands by itself. It's very inexpensive and has a very short return on investment. But what's powerful is when you link this up into CreateASoft as another data input, so that the CreateASoft system end-to-end data digital twin can optimize the entire environment. With that, I'd like us to start off with a survey just to get your feedback on ranking in order your concerns in deploying a digital twin. Is it IT pushback? Do you need operational standards first? Do you feel like you need those first? Maybe it's accessibility and or availability of people and resources. Is it the overboarding cost to implement? Do you feel like you can get a return on investment by going down this path? I think both Wiser's and CreateASoft has a long history of being able to achieve ROIs well under 2 years, even under a year in most cases. Is it the system integration you're concerned about? That's also a strong suit for CreateASoft. And then, or are there production disruptions when installing the systems? And then is it training of personnel or readiness? So we do have a few responses. So we can go ahead and see what the priority is. So data accessibility and availability, integrating with other systems, which I think we would look at as an opportunity because it's not as foreboding as you may think. And there's ways to do that so it's not overwhelming your resources. And the readiness for digital transformation also there, and then cost to implement. Hosni, any thoughts on this slide or what you've seen?
That's actually pretty in line with what we normally see. And I will address data and the main two topics there, the data accessibility, the integration piece in detail as we go along into the next section.
Great. If you have any comments or questions on this, please do enter it into the chat in the Q&A. And I think this is Hosni, you can go ahead and take over the screen at this time. Thank you for continuing to answer the questions. Appreciate it. Yeah, go ahead.
All right. So, so this is really our main agenda now, is just to go into the detail of what the data-driven digital twin is, how to get to it, and basically address some of the key issues that you always run across, whether, availability of the data, connecting to these data systems, and actually make the digital twin as accurate as it can be with your actual real life environment. The goal of everything we do is a turnaround of 30 to 90 days, depending on the implementation itself. The reason that's critical in applying and getting that digital twin up to speed is that a lot of the operations today are constantly changing, whether it is, your routings are changing, your schedules are changing, the way the products are moving through the operation is changing. And for that, the shorter the time span you get to a digital twin, the better you are equipped to actually utilize those tools and the benefits of the actual digital twin implementation. So one of the key things is really to to identify the differences between the different twins that are available. And one of the key thing is I normally like to break it down into 4 different types of digital twins. There's the visual twins, which will give you the visual representation of the operation. By the way, in some of the other webinars, I actually go into this in a lot more detail. So I'm going to summarize that for everybody. And then from the visual twin, you go into the randomized twin, which a lot of companies who have done some kind of a digital twin implementation or have done some simulation at a large scale have used randomized twin as the key component at this point. But to actually get the true accuracy and the data that you need, sorry about that, you really need to get to the data-driven twin. And that's where the data becomes critical. The connectivity to these data components become important. And that's where you will gain the most out of that digital twin tool that you bring in. The data itself is not as a constraint as everyone might, as you guys will see here in a few minutes. From that point, you get to the actual learning AI-driven digital twin, where you kind of bundle a neural network built into the twin. It will learn how the operation behaves. It'll give you predictive on what's actually going on. And this is really the final result of where everybody needs to get to from a final operational digital twin implementation. So with that, the key to the digital twin is, and for any project on any implementation that you do, is first you have to define what you want to do. Depending on the path that you want to take, you will identify which implementation you will go through and implement. So if you're only looking at visualization, and visualization is good. I mean, it's not, I don't want to make it sound like it's a bad thing. Actually, visualization will help you convey ideas, new flows, new patterns, how things will move, and so on. But if that's the only target, that's the only value that you need. So just stay with the visual twin. That'll give you what you need. It's a quick ROI, and then you will move on. The key there, if you want to do anything beyond that, if you want to do operational analysis, if you want to figure out what's actually happening within the plant, if you want to understand that operation in more detail, you actually go into the randomized twin. And then based on the next set of steps that you need, whether you want to use this twin in an operational aspect, whether you want to really use it as an accurate representation of the plant, you want to use it for scheduling type scenarios and so on, that's where you actually need to start going into the data-driven twin. So it's really driven by your data set. And I'll explain what that means. But to actually do that, you have to develop a plan. Just like any project, if you say, I want to create a digital twin of my whole plant, and start with that idea in mind without actually developing a true plant and breaking the plant into sections, identifying where the most ROI is going to be, and then validating the twin as you go along, you actually will not get to the state, and the project will be derailed as you go forward. Once you have the data-driven twin, the next phase will be to connect it to real-time data and actually start to pull multiple components together, multiple data systems together in order to establish that real-time aspect of the predictive and prescriptive analytics that the digital twin will provide. So just this is a sample twin. So this is basically a sample digital twin, and I'll just run the animation. And from the view of it, you really don't know if it is a true representation of the plant, if it is an actual visual twin, if it's a data-driven twin. It just looks like a lot of animations, a lot of things moving, and that's where you need to start to create those differentiations. Is what is actually are we trying to show in this specific model, and why it's important to actually have the visuals along with the data and the data that drives it. So this is kind of an example of a digital twin that is presented. It can present a specific state of the operation, or it can present a a full 1 day or a week worth of data that's actually you cover within the plant itself. So we're going to just concentrate on the manufacturing side today. There will be another webinar, as Jim mentioned, that will target the warehousing aspect and the picking and all that other part that's on the warehousing side. So from there, if we look at the visual twin by itself, it really doesn't have a lot of value from an analytical point of view. So I cannot say how many people do I need to run the plant, what is my downtime impacting my schedule, when should I do my maintenance, do I have CIP that I need to run, and how do I schedule those so that I can minimize its impact on the operation itself. All it's going to provide me is a visual that says this is how the flow will work. So if you look at that animation that I was showing, you actually will get the idea that there's some production, there's the products are actually moving on a conveyor of some sort. They're going to be palletized, put on a storage system, and at some point being picked up from the flow. So the digital twin, the visual digital twin, is actually going to give you that, but that's where it stops. So it's very important to identify that. Now, if you developed it, if the plan was initially to develop a visual twin, then you will have an animation that is a 30 seconds, a minute, 2 minutes animation that will show the flow, but it doesn't have data. It doesn't have analytics built into it. And that's where the actual randomized twin will actually come in and actually give you more representation from an analytical point of view. So everything that we're going to do is going to be driven by having a randomized twin as the minimum that you would need in order to perform some kind of an operational analysis on the floor. Now, the randomized twin is going to be driven by system constraints that you define. It's going to have some changeover. It's going to have cycle times. It's going to have tooling requirements and so on. Those are all going to be built into the data, the randomized twin. The only thing is everything there is randomized, and everything is built based on distributions that you actually will put in. So you will say it's going to take me, anywhere between 5 minutes. 5 minutes, so let's say 10 minutes to perform an operation. It's going to fit some kind of a distribution, we're going to use that to model the operation itself. So it will have the visual and it will have the constraints, but everything is driven by randomized data. And one of the key things to keep in mind here is the data should not fit the distribution, but the distribution should fit the data. So this is very important as you're performing those randomized twins. If you go the way where you try to find the distribution to fit your data set, then you're really not applying the true data component into the randomized twin. So it's very important when you do that data fitting to actually make it open enough so that it does not have to be a distribution that is a known distribution. It doesn't have to be a normal distribution. It doesn't have to be a triangular distribution. It has to be a polynomial that fits your data set. And this is a key component there where we see quite a bit where everybody says it's an exponential distribution of my data, and this is what I'm going to use. When you actually look at the data, it does not fit properly into an exponential, but it could be a different type of polynomial. So from a digital twin perspective, a randomized twin, you can pretty much have all the components there, but you cannot really optimize randomized data. So this is really the pitfall of the randomized twin. And you can generate different analysis. You can figure out how things are going to work, how the flow, if you're going to have some backups, some bottlenecks within the operation. But it's really not going to allow you to optimize in a good way what actually happens within the plant. This is kind of the implementation that we ran through when we did this high mix manufacturing operation. So just to give you an idea of what the operation is, In here, we've got, basically finishing machines. This is all manual, by the way. There's some material handling that actually happens. There's some CNC machines that you see on there, but everything is a manual operation. Inventory is spread out throughout the operation. On the right side, we have the office that's actually running the operation. And then there is some WIP that will be staggered pretty much everywhere within the operation itself. This is all manual operation. This is manual operation to load those CNC machines and actually operate them, and so on. Now, one of the things that we did when we implemented the first phase of the implementation to actually get the initial digital twin set up is we actually took in randomized data for the operation. So we put in all the tooling, all the randomized data that fits how long it takes the CNC machine to load, unload, how long it takes to move slabs from one location to another, what's the finishing look like, how many pieces you actually generate out of each CNC cut. So all those were put into the model from a randomized perspective. So this is a view of the operation actually from a representation point of view, just to kind of give you an idea of what the operation is. Things come in from the inventory section. They get scheduled on a CNC station. That CNC will generate a number of cuts that are created. Those will go into a polishing station and back to a finishing area before they actually are ready for a final QA to be tested. So it is a simple operation, but it is a high mix operation, which means every single slab is going to be going into the CNC machine one or more times. It can generate a different number of cuts every single time. And the finishing area will vary based on each job. So it is a kind of a built to order type operation. And every single item of it will vary from a cycle time, from a changeover, from a tool perspective. Now, what you'd notice there is we actually did run analysis to see how the Wiser tools will actually implement and improve the current operation. So what you see on the side there, these are actually Wiser cabinets that are used to improve the wall that was full of tooling. So the wall that you see there in the back, this was all tooling that's available to everybody to use and consumables. So those were transformed by the Wiser machine to actually control that consumable. And as we see, when we transfer to the data-driven twin, it actually had more control over which job took how much tooling, how much consumption I was using from the consumables, and I was able to get a better cost on each one of these operations as they go along. So needless to say, this is probably the same for every single operation you would see. Scheduling is a major bottleneck. How do I schedule the operation? What job do I start first? And, and who is controlling the schedule? In every small operation like that, there is, and actually larger operations too, you're going to see one or two people that are actually controlling the schedule. They understand the details of the operation, and they are the scheduler. So in this case, scheduling became a major bottleneck in the system. So how you schedule those CNC machines, how you move that fork truck close to the CNC and load them with those heavy slabs, that actually had a huge impact on the schedule and how it actually run. The CNC machines, they were very highly utilized. There was always material on the CNC machine, but they were not as efficient as they can be. So basically what you would see is the overall efficiency of the machine itself when it's operating was low, but it looks from the plant perspective, it looked like all those machines were very busy. And one of the things they were looking at is, should we buy another CNC machine and spend another $300,000-400,000 on a CNC machine to actually get it up and running? So material handling is definitely not a constraint in this case. There's plenty of material handling that's available. It's just that the cross-training did show from the digital twin that it is actually a constraint, and then it allowed the actual job jobs to shift from different positions. So you would have bottlenecks that kind of shift with the operation. Now, the one thing that we noticed is when we presented the optimized data and the data, the findings, the accuracy of the model was really around 90%. So it's good for analysis to give us good insights, but it's really not enough for us to really do a scheduling implementation or improve the efficiencies of the CNC machines. Just because 90% is going to give you 10% of inaccurate data that will be played in. So that's where the first step actually gave us a good representation of the operation. And then we moved into the data-driven twin by tying in those data components into it to get to the more accurate representation. So from a data-driven twin, the key to it was to load the actual data set. So if they are running, for example, if we want to look at the analysis for a week, what are the transactions that actually fueled that week? Whether they are the jobs that need to be handled, the personnel that's actually running the operation, the type of jobs that are set, the type of material being used, the number of cuts generated, and the amount of time it takes on each one of those machines. So that was the transactional data that we fed the model. We did not feed it a distribution of CNC timing that will vary based on a specific distribution set. It was the actual transactional data that actually went into the model. So at the same time, you can take that into a different operation. That could be truck arrivals. And in the truck arrivals, you'll have each one of the SKUs identified as part of your implementation itself. Order detail, the bill of material that's required for each one of these products. All those are kind of key data. You have to have that data to run the plant regardless. So that will be the data that actually will feed the data-driven digital twin. Now, historical production and maintenance data, this is all good to actually create some kind of a historicals on how the model and how the digital twin behaves in general. And that will create trends within the model to allow you to see what kind of interruptions you have, how many times the CNC would fail if you're working on a specific type of jobs, for example. So that's where that data came in. And again, if you're running any type of operation, you're going to have the transactional data because that's required for you to run the plant. And historicals is available if you're doing any reporting from there. So this is the transactional data. I don't need any analytics to tell me I'm using utilization of a certain percentage, or I'm using 80% of my people, or whatever that value is. I just need the actual data that ran the operation. So the goal for that is to actually create an exact replica of the plant. It behaves like the plant. It reacts to the data the same way that the plant would react to the data. And what we actually achieved is 99.2% accuracy in the model that was generated. So when we run the data through the digital twin, now I can use that model to schedule. I can use that model to optimize my CNC operation. I can use the model to modify how the resources are allocated in order to get the best lead time and improve the efficiency of the operation. So what we tied in with all this is the actual value stream mapping of the operation. And this is kind of one of the outputs that we always generate out of the model, is a value stream map, a heat map showing where the actual load is from a width perspective or utilization perspective, and of course the spaghetti diagram to see how your traffic and congestion actually play out. So some of the key steps that we learned basically as we go through is, first, you need to identify the data. This is kind of the first thing that came out from the polling, is the data set. So the key to the data set is you need to load the transactional level data of the plant. And that's really the main component there that you need to identify. It could be time-stamped. It will identify every single SKU. If you have the bill of material for the SKU that you ran, that will be the transactional data. Now, be very careful there. Just because I load transactional data doesn't mean that once I put it in a digital twin, I'm going to convert it to a distribution. I'm actually going to run it the way it is. If I do convert it to a distribution, then I wasted my time loading data, because now I moved back to the randomized twin, thinking that I'm actually using my data to run. In fact, I'm using a randomized set of my data. So it's very important to differentiate between those two aspects of what that transactional data is. The other very important aspect of it is you've got to validate what you have. Having a model that looks good, a digital twin that actually looks really cool, has a lot of graphics, it runs, it animates, that's not validated is useless to anyone. If you have to make sure that your model is valid, and I don't think I can repeat that enough times, as far as how the validation of the model, how important it is to make sure that it is valid. So be careful there. As you validate, you can run any state. You can pick last week's data and run it through. It should behave the same way as the plant. If you optimize the plant and you run last week's data, now you can see how I could have ran that week and where I could have gained my efficiency. So you're comparing actually apples to apples in that case from an optimization perspective. That's an easier way to sell to everyone who actually will be impacted by the change as you go through. So this is basically an example of the data-driven twin, and this is another implementation there. The model itself is the same. The difference is that now it is driven by actual data set. It's actually giving me that data that represents my operation, and I'm getting metrics that are believable, that relates to my operation. The visuals don't change. It's just what actually happens in the background and how the digital twin actually behaves. The only downside to the data-driven twin is, by default, is not a learning system. It does provide predictive analytics going forward. It does allow you to optimize your schedule and perform these type of operations, but it does not give you that learning prescriptive analytics that is required. So data that we normally like to put in a digital twin and a data-driven twin is basically, it ranges, and any one of these sets will help you get to the digital twin operation. Any plant should have those, and in some form, whether it's in an Excel file, in a database somewhere, so that data could be imported into the model and drive the model. You don't have to have the connectivity to the actual systems to start a data-driven twin. You need to have access to the data in order to get it into the model. Connectivity comes in as a second step. Once you have that data structured, then you can actually tie it into the actual systems, whether it's your ERP or SAP or whatever the job scheduling that you're using to actually generate that data. So by having that, you will actually be able to generate a true exact representation of your plant and run it exactly the same as you would have in the operation itself. So some of the key things to watch out for is you're using this to actually analyze the whole plant. And a lot of people would put it on a laptop that is 5 years old and allow it to run. And then if you're putting so much emphasis on that digital twin giving you the data that you need, make sure you provide it with enough hardware that actually meet and exceed the specs of the hardware. This is very common. You'll be amazed how many times that happens, where people will spend thousands in creating the data-driven twin, whether from manpower and software and so on, and then they put it on a laptop that costs $500 and everything slows down, and that becomes the problem. Again, transactional level data, that's very important to actually perform the data-driven twin, the validation aspect. And the one thing that we see quite a bit in the industry is that what I call the 3D syndrome. You look at the animation, it looks great. It's amazing. It's a wow factor, but it has no relevance to any analysis that we will do on the plant itself. So be careful as you go through that. Ensure that you have a change management plan. So as you go through, you'll actually have a path forward in order to implement the changes that the digital twin actually gave you, and be able to roll it out based on very specific milestones. So treat it as just any improvement process that is within the operation itself. So this is kind of a connectivity matrix of what we connected to from a digital twin, data-driven twin perspective. Connects to basically your SAP, ERP, WMSs, and whatever data points that you have on there. If you have any location devices, that actually will come in handy, like RFID or GPS or any tracking devices that can help identify and improve the accuracy of the digital twin. And again, any other tooling that you would have. An example is that, the Wiser system, but you can have all these tooling actually feed into the operation, and that will help you integrate and provide better representation, better optimization, and analytics out of the model itself. So again, some of the key benefits of a data-driven twin, just to reiterate that, you have very flexible reporting that you can do. You've got an environment that you can actually do data mining on and get the detail of the operation, and use a lot of it for predictive real-time information. So you can use that data-driven twin to see how the operation is going to run today. Before the shift starts, you run the shift through the data-driven twin, and it's going to tell you where you're going to have issues. Again, since it's an exact representation of the plant, it's going to be very, very accurate in the way it provides you that data. Now, once you go to the learning and prescriptive twin, then it'll tell you, guess what? This is another way where you can reschedule, for example, or optimize in order to run things better or avoid any bottlenecks that might occur. So those surprise events that actually will come up will allow you to be more proactive in the way you run. So you don't wait for the problem to happen to react. You actually prevent the problem before it occurs. That's really the key there to that data-driven twin, once it transitioned to be an operational type tool that you're using on a daily or hourly basis in some cases. And then the cool thing about this whole thing is you can actually get an ROI in less than 3 months. So you can implement a full digital twin, data-driven twin, that will transition into a digital twin model in 4 to 6 weeks, and go through the validation and the data import, and actually have that operational in 3 months. And that has been done in many cases. I can share some case studies offline if needed. So one of the key things, if you do transition from the data-driven twin to the real-time twin, that's when you actually start adding the predictive analytics into it, the prescriptive analytics, I should say, into it. And that's where we tie in a neural network that actually learns from the operation, that allows you to ask questions and provide dashboards throughout the system in order to provide that prescriptive aspect to help you identify future potential issues that might occur. So it connects to PLCs, it connects to the ERP system, but at that point, it's connecting in real time. This is where the connectivity really comes in. You don't have to have that connectivity early on in the process, but this is kind of the real-time data-driven twin will actually start becoming a component. We didn't get there in this implementation yet. This is the next phase of the implementation where we actually do the predictive. We're just giving them a couple of weeks to adjust to the new change before we jump into the real-time digital twin data that's consuming data from the PLCs. In this case, it's going to be mainly the CNC machines that are feeding data back in. So just sample dashboards that you would see from a data twin. I mean, again, these are all customizable to anybody to what you need, and they're constantly updating based on the data itself and what's actually happening within the twin. So with all that comes a lot of change management, and that is required for identifying the right people that are actually running the operation. So Jim, do you want to touch on that?
Sure. Thanks, Hosni. As Hosni mentioned, the change management aspect may be one of your greatest opportunities or challenges of linking that business strategy to the business results. One of the tools out there that's really powerful is called Predictive Index to help you design your processes of how you work together and make sure that if you do need to hire people, they're the right people and the right fit from a behavioral perspective to drive. And then how do you drive and inspire your current people for this overall change? And then there's a diagnosis part of Predictive Index that can help you on your journey. So you still need to go through the change management practices. However, your ADCAR or whatever process that you're choosing to take, a business transformation, change acceleration process. But having this in the background of helping the people understand what role they play and what their strengths and weaknesses is very powerful. So just a little bit about Predictive Index. Predictive Index has been around since the 1950s. It's basically, you could say, Myers-Briggs on steroids. It only takes about 5 minutes to take the survey, and they classify you into different groups. One is cultivating. Those are folks that are focused on employee commitment, morale, development. Engagement is a big deal for that group. If you're exploring, those are the people that want to pursue opportunities, those type of things. Success, new product and services are unique to the market generally. Producing, to focus on accumulating clients and build on the reputation in the field. Or do you want to be, from a strategic intent perspective, do you want to be stabilizing? So these are all the things from a goal perspective that you want to do. Generally, it fit into these 4 categories. If we're doing a digital twin, we're kind of doing a number of these. We're cultivating the employees, we're exploring a bit, and then of course we need to produce, but then we have to have a stabilized environment. So we want to find out what are the type of people that are going to help pull the effort forward in the right direction, and who do we want championing those efforts. So when you do take the survey, it will tell you what type of person you are. Are you a collaborator, a promoter? I happen to be a promoter. Are you a maverick, persuader, or a captain, or a venturer? One of my partners is a persuader. A couple of my partners are persuaders. Are you producing? You're a strategist, or you're an analyzer, you're scholarly, or are you stabilizing? So just in a very short period of time, if you know who you are and how you can contribute to driving over that overall strategic vision of, in this particular case, digitizing the manufacturing floor, you can make sure that people are aligned with their strengths to pull you in the right direction. And if you're missing somebody and you needed somebody in a particular area, you could bring them in to coach others on how to get over that particular threshold. So, and then there's flexors. The last group is people that can go into all the different areas. They're adapters, they're alters, individualists. So again, putting together that team that's on the ground and making sure it's well-rounded and filling in where you need to is a key to this, to make your deployment successful. So with that, Hosni will take over. And Hosni?
Yes, thanks, Jim. So this is just some of the implementations that you see from a digital twin perspective, whether it is the predictive aspect of it or the prescriptive aspect of the implementation. So these are data that are coming from the digital twin identifying what will happen in the operation. Some of them are the true state of the plant at that point in time, while others are what will happen going forward. So if you look at the chart that's on the left there, it's showing what the current representation is. It's showing what the standard is for that specific schedule, and where the item is now in the sequence. So it's a combination of comparing your current representation and what the digital twin thinks the progress of that specific item is as it moves forward. You can apply that to different types of the operation. It can be to the job, it could be to the resource, to the personnel, it can be to the material handling, to the efficiencies. All these could actually impact that operation itself.
So, Hosni, we do have a question coming in here. It was asked a bit of time ago. It's from Mark. He says, we've been loading transactional data and converting those data into distributions, but we aren't always getting accurate, actionable results. I think you covered this, but you might want to cover it again for Mark. How can we modify our data input to get a better solution?
Yes, so this is really, it relates to taking transactional data and where the tool itself will convert it in the background to randomized distributions. So you actually lose the value of loading transactional data at that point, and which is basically what Mark is experiencing. It's really the tool itself needs to be consuming the data itself the way it was loaded and not generate the distribution out of the data. So if you generate distributions, then you get into the inefficiencies of the randomized twin. And then you basically spend a lot of time loading data that you're not using. So we make sure that whatever data is being used, the transactional data is actually consumed as transactional data, and it's all time-sensitive data. It's got the actual quantities, volumes, weights, and whatever other components are associated with it is what's actually running on the digital twin, and that's what will get you to the high accuracy models that you can use for predictive implementation, predictive analysis.
And then I just wanted to add something that we often forget to say is that, you know, you have discrete events and you have continuous events. And,
correct.
And what's unique about what Hosni has created is the ability to manage both types of events and integrate them interdependently. So Hosni, a few more words.
Thanks. Yes. So basically in a lot of operation, you actually have a kind of a continuous flow type operation that'll eventually become a discrete entity. So, you know, if you're filling, you know, I'm going to use Coke as an example. If you're filling Coke bottles, you start with a liquid and a mix, and then at some point they become a bottle, and it becomes a discrete entity that has to be transferred. So that transition and those, you know, the transition from a continuous flow to a discrete event flow is something that that we have implemented quite a bit, and it's very common in today's, you know, whether it is the food industry, whether you're in pharmaceutical, and you know, in a lot of different construction type operations and so on. Got to be careful which ones I mentioned, but that's really where that value comes in, and it follows the same data set. I mean, it's just the data that you load is going to be different, but the actual sequence of implementation remains the same. So this is another example of what you can get from those digital twin, data-driven twin, and it's also giving you that comparison of what's happening live and what the digital twin is going to show you is going to happen going forward. So you have that look ahead into the future to identify those metrics, and you can change those any way you want from that perspective. Want to go to the next one?
Yeah, just closing out the webinar. We're just about the top of the hour, so I think we're all right. We just wanted to reiterate how we would do this in 90 days. People say, how can you do it in 90 days? This is the how. We're not going to go through this in detail, but we do follow the 5 steps of assessment, piloting, implementation, integration, and optimization. And this is the roadmap that we follow in that 30, 60, 90-day action plan to get that return on investment for you. Anything you want to add here, Hosni?
No, that's perfect, Jim. I mean, the key is what I always tell people is if it's going to take you 90 days to build a digital twin, or more than 90 days, then most likely you're building a digital twin for a plant that doesn't exist anymore. So you just have to make sure that that twin is created quickly enough and is able to adapt to the variation that you have within the plant. So adding a new item and adding a new SKU and new routing is all built into the twin, so you don't have to always go back and modify it and apply those changes to it. The data-driven twin should be able to adapt and basically include all those things. That's what we integrate all the time in that in the digital twin implementation that we do.
And just to summarize, some key learnings that we discussed today, the real-time predictive analytics is achieved through the data-driven digital twin. That's one of the first things we discussed early on in the sequence of events as far as making data a competitive asset. It is a journey. What is really unique about CreateASoft is we can accelerate that journey that used to take years to get through. We're able to do that in 90 days. Of course, we just talked about the second point already. And then, of course, the elusive tooling and consumables that a lot of folks, we say, oh, we'll get to that later, but tends to mount on things. And then when you're missing the right tool, the risk events that are incurred because you've lost tooling or consumables, you're not tracking them, your whole line may be down, or you may have to do a changeover at that time. So the amount of money that you can save on tooling and consumables of localizing and tracking it and really linking it up to your inventory management push-pull system can be very, very lucrative to you. And of course, we introduced the change management piece. We do believe that people, process, data, technology. Without the people and process, the data and the technology won't survive. So you need that. And of course, the learning neural network, that's a lot of words, learning neural network, data-driven digital twin does provide that optimization in real time to deal with your dynamic constraints, because your constraints are changing. So as soon as you build a model, it's no good. And what's really unique about what CreateASoft does is, as your constraints change, by taking real-time data, you're actually able to adjust for them in real time. So the person out there on the floor is working on the right thing. So every day or every shift, we have daily meetings. What do we do? What's next? There's directions on the floor. Oh, this came up. Well, if that would be all in the real-time data digital twin, it's in the digital twin. So all those constraints, the new constraints are in there. So the workflow actually is going to go much, much smoother, and people can be much more productive on the work floor. So that's a little bit about the data-driven digital twin. We're coming up against the hour. If there's any more questions, please let us know. We'd be more than glad to help answer those. If you have any roadblocks, please do reach out. If you have any that you can think of now and you want to type in here, that would be great. But we are at the top of the hour and we want to respect your time. So thank you for joining us. Hosni?
Thank you, everyone. Appreciate your time.
So again, there is a way to get to high availability rates in a very short period of time. And on behalf of EIG, we appreciate you joining the webinar. We'll be having a few more webinars in February on supply chain risk management and new product introduction. and we hope to see you there. And this is of our 50 partners. We thank you for joining us, and we look forward to future webinars.